projects, in specific European Union projects. Sébastien is going to talk about Meetween, which is a project that has been, I think, started recently, but we'll know more in his presentation. So just to introduce Sébastien Bratières, he is the managing director of the PI School and the director of Artificial Intelligence at Translated. Both are located in the PI campus in Rome, in Italy. Sébastien holds an engineer degree from École Centrale Paris and an MPhil in natural language processing and speech recognition, and a PhD in statistical machine learning from the University of Cambridge. Sébastien developed different approaches using machine learning, specific non-parametric model for structured output prediction, and earned several awards and grants for his contributions to AI research over the years. And he has developed various AI products in the industry, including Europe's first quadrilingual consumer-grade speech-driven telephony platform. He also participated and led NLP technology for virtual conversational assistants and embedded speech applications for logistics and manufacturing. Sébastien is currently leading the Meetween EU project, and this project, as we will know more about it, is focused on solving speech through foundation models, along with several other AI-related European projects. So it's very nice to have you here, Sébastien. I give the spotlight to you.
Thanks, and I'll take over the screen then, if I may. Yeah, so that's sharing to everybody, I guess.
Yes.
So thanks for the intro. Yeah, solving speech, quite a mouthful, obviously. Let me introduce the project very quickly. So it's in the same call as Utter and Eloquence. So it's running. It started in January this year, and it's running until end of 2027. Partners are Translated and PI School. So I'm with both companies, like you said, José. Fondazione Bruno Kessler in Trento, in Italy. Zoom Research, also Karlsruhe Institute of Technology. Taus, which is a partner that is specialized in data for language in general. Taus started off in data for machine translation and now works on language data in general. Technical University of Istanbul. There's a group there who's collaborating with the project, and they're specialized in like lip sync and video aspects of speech. And Cybernet, which is the national HPC provider in Poland. So the areas that we work on, large multimodal models applied to speech, speech-to-speech translation, and we apply all this to virtual agents for video conferencing. So let me say a word about the application that we have downstream of this project. So the way we conceive of like the future of video conferencing, or the aspects we'd like to work on, is where we have a sort of a multilingual table with people who speak different languages around the same table. We give them tools in the form of agents, and I say a bit about these in a second, to interact naturally with in their own language with the people speaking other languages around that. So that means we're thinking of two agents in this context. One we call the butler, and that is a sort of meeting secretary or meeting assistant. It's the agent that takes care of minuting, summarization, catching up people when they enter a meeting later, when they need to leave, and deals with agenda reminders, diarization of the meeting, and so forth. And then agentar, which is a portmanteau between agent and avatar. So it's that agent which stands in for absentee human participants. This is obviously the more, I would say, socially challenging of the two, It's the one where we have a lot more social sciences and humanities and UX research behind. We want to figure out a lot of things about it to not make it awkward that an agent, this one here or this one here, participates in a discussion with humans and makes use of information that you have or that your company has and that the agent needs to know in order to represent you at that meeting. So we need to figure out what exactly are tasks that can be carried out or delegated to agent are, of course. And the idea is that they take on some aspects of the likeness of the absentee human participant themselves, and in the same goes solve the multilinguality problem as well when they address others. So in terms of I'd say deliverables, these are the things we'll be pushing out. So major deliverable are speech foundation models, and I'd say a word about these a bit later. The data that we've been using to train these models, task-specific models, which are effectively derived, like downstream task models derived from these models here. And then performance benchmarks. So SpeechM is, the inspiration for us is glue and super glue in essence. So it's a set of benchmarks for a number of downstream tasks that can be sort of executed on the same platform with a predefined set of metrics, predefined splits, and we can get a unique metric as the measure at the end. So what we reason on in Meetween is speech in all its dimensions, essentially. So it's text, it's audio, and it's also the video component. All three of them obviously synchronous and many things happening in the three modalities. So we're looking at all the phenomena that happen across these things. And while there's much work currently, obviously, on both text and audio, there's a bit less on the video aspect and the synchrony between audio and video, but then also video and text at some level. And so we'd like to tackle that. So the sort of, if we take the view of downstream tasks in terms of the foundation model terminology, downstream tasks are tasks that downstream models can execute, zero shot, few shot, what have you. So we have these perception and generation tasks, and they all correspond, or they afford some of the functions that our agents are meant to carry out, okay? So the reason why we work on these tasks, essentially, with using these foundation models and all sorts of transfer learning thinking here, is because then we can make these agent functions work. The trends that we are riding or that we're contributing to are the ones that you already know. And in fact, it's, I found it really exciting that Marceli was reporting on MUBERT, because this is the exact, speech representation. This is one of the things that we need to utilize because it's instrumental to modality adaptation. And this is something that we need to use in order to make, to let LLMs work in different modalities, both in input and in an output. The other ones obviously are unsupervised pre-training to build LLMs that can carry out a diversity of tasks using unsupervised material, essentially. So in our case, unsupervised is one class of material that we like to use, one class of data that we'd like to use a lot, is something that occurs, I would say, in nature, which is synchronized audio and video, obviously. So in our setting, what we mean by video is the kind of image that we have of one another here in this video conferencing. So it might be the video of a speaker who doesn't move. It might be just the upper body part. It might be just their face, but it certainly captures things like gestures, head orientation, gaze, and so forth. So this is a self-supervised type of material that we like to use. The next things that are going to happen in Meetween, so we're speaking, Q4 2024 or Q1 2025. So we're defining the tasks of interest for SpeechM, the benchmarks that we're going to release. So we've got speech recognition, speech-to-text translation, and speech-to-speech translation, but then also summarization, which is a task important for video conferencing, temporal reasoning about a discussion, diarization, lip reading. So, one derived task from this would be ASR enhanced by video. So completing the task of recognizing words just from audio by recognizing words from both audio and video recording of mouth movements. And in terms of models, so our objective is to have our first version. We have several generations, if you will, of this speech MMM large multimodal model here on Hugging Face around beginning of next year. And so for this V1, what we're targeting is audio, text, and video as the input, and then audio and text as the output. And for future versions, we'll also target video in output. And so currently what we're looking at is the sort of architectures that have an LLM backbone and then have modality adapters in input and in output. So you might have heard of these models. These are inspirations for us. So Salmon, AnyGPT, Audio Flamingo, Speech GPT. And I don't need to speak about, so since we have a few more minutes, I guess I'm within time. I want to speak about the sort of scientific inspiration for the work. So I don't need to speak about Hubert because Marceli did that, better than I ever could. And so keep in mind that this self-supervised representation learning for speech, this is one of the things we need to make these speech MMMs work. And then the next step up, if you will, is when, in addition to looking at the speech signal, the audio version of speech, we also look at the video modality. And we look at models like AV Hubert, which are extensions of Hubert to the audiovisual domain, where with the exact same thoughts really than we have in Hubert. So this is, an illustration here for masked loss learning here. And then the versions of discriminative losses that allow us to do unsupervised, self-supervised, like learning for this for this model. So this is another example of what we are, like the state of the art that we're leveraging, if you will. Seamless M4T, another meta project, is another take on another idea that motivated Meetween when we wrote the proposal, where we have again the same backbone model, the same pre-trained models as the backbone that support a number of tasks after architectural adaptation in their case. And the same, comes up in, or has come up, I would say, in models ever since we started the project. So Seamless M4T was after we wrote the proposal, but before we started the project. VSP LLM was in February now. This is after we started the project, but it's the same thinking again. It's where we have like the same LLM backbone supporting here input in terms of text tokens and video, and in our case also audio tokens. So it's this, this scientific field or these scientific ideas that we're trying to leverage, and with the outputs, with the deliverables that I mentioned earlier. Thanks, I'm through with my presentation. And if you have any questions, I'd like to try and answer them.